Welcome to the Crazy Head Chemist. So another video here on kinetics. So let's get moving. Bam! So an Arrhenius calculation number 1. Let's see what this one entails for us today. All right, the activation, we're going to calculate the activation energy, that's E sub A, given the following data. So we have two rate constants and we have two temperatures associated with those two rate constants. So the first one on the left-hand side is K at 650 Kelvin is equal to 2.15 times 10 to the negative 8 liters per mole second. The second one, the second rate constant, is at 700 Kelvin temperature is equal to 2.39 times 10 to the negative 7 liters per mole seconds. Okay, which equation are we using? We are using this equation, which is the two simultaneous equations of the Arrhenius equation. So that's natural log of K2 divided by K1, those are the two rate constants, is equal to negative E sub A over R, that is the gas constant, is the R, times 1 over T2 minus 1 over T1. Okay, we are solving for the E sub A, the activation energy here. So we've got two rate constants and we've got those two temperatures. So it doesn't matter which rate constant and temperature you call 1 or 2, it really doesn't matter. I'm just going to arbitrarily take the first one as the 1 position and the second one as the second position, although that really truly doesn't matter as long as you keep them consistent. That is, keep the rate constant with rate 1 with the temperature 1 and the rate constant with rate 2 with the temperature for 2. Okay, so let's plug in those values and see what we get. Okay, so I've plugged in those values here, so now I got natural log of 2.39 times 10 to the negative 7 liters moles seconds divided by 2.15 times 10 to the negative 8 liters moles seconds is equal to negative, don't forget about that negative sign right over there, and I've highlighted the E sub A, the activation energy, and that's what we're solving for. I've plugged in the R value, that is the gas constant at 8.3145 times 10 to the negative 3 kilojoules per Kelvin mole. Okay, and I've also plugged in the two temperature values associating the K2 with the T2 and the K1 with the T1. So that's 1 over 700 Kelvin minus 1 over 650 Kelvin. So what we're going to do here is we're going to simplify that left-hand side of the equation. We got a little division here. Our units are going to cancel out. The liters, the moles, the seconds are all gone. We got a division of those two numbers and then a natural log of that quotient. And then what we're going to do is we're going to take those two temperature values on the far right-hand side of this equation and do the reciprocal and take the reciprocal of each of those, subtract them, and we're going to get a number right there. All right, so let's see what that pops up to be. There we go. So on that far left-hand side of the equation, I've got 2.41, and on the right-hand side, I've still got that negative sign. Don't forget about that negative sign. The E sub A is still highlighted in yellow because that's what we're solving for. Divided by the gas constant, I've taken out the units because I know that my E sub A that I'm solving for is going to be kilojoules per mole in this case. Those are the only units I'm not canceling out here. And then I got the difference of the two temperatures there at negative 1.10 times 10 to the negative 4. All right, so this next step, what we're going to do is we're going to move the gas constant to the other side with a multiplication, okay? And then we're going to use the difference of the two temperatures and move that to the other side with a division. We're also going to get rid of those two negative signs as well. So the negative signs are going to disappear because we got two negative signs in here and those are multiplied to be a positive. Okay, so let's see what we get when we get this here. So I've moved those numbers over, I've gotten rid of the negative sign, I've placed those numbers where they belong. So now I have 2.41 times the gas constant, which is 8.3145 times 10 to the negative 3, divided by the difference of the two temperatures, 1.10 times 10 to the negative 4. I'm going to plug this into my calculator and I'm going to get my E sub A value this time. So here's my answer of the E sub A. It's 182 kilojoules per mole. Okay, those are the units for the activation energy barrier. Remember, the activation energy barrier is the minimum amount of energy that is necessary to make this reaction, to the minimum amount of energy required for this reaction to proceed from the reactants to the products. And you need to overcome this barrier in order to get over to the product side. Okay, So I hope you enjoyed that one. We have two more different types of reactions. Sorry, we have two more different, the same equation, but two more different things to solve for. One is going to be the rate constant. One is going to be the temperature. Think about that. Don't forget about the hat here. Here comes a crazy hat. And I hope you like octopuses or octopi, one or the other. And give me a thumbs up if you like that video. Subscribe to my channel and find me on the web. I've got a great website set up for you with all my videos organized thanks to my son. And there's worksheets to boot. All right, I'll see you next time. Bye for now.